Hello students, so today we will do the numericals on work energy of electricity as well as Joule's law of heating, the theory of which was explained to you in the last session. I hope you have revised the formula and come in brief. I will revise the formula that we have done. We started with current I is equal to charge flowing per unit time. So I is equal to Q upon T. So the first formula that we had derived was I is equal to Q upon T. Okay, so this was the first formula that we have derived. I is equal to Q upon T, where Q is the charge, T is the time. Charge is measured in coulomb, time in second, then I is in ampere. So this was the first formula of the then we derived what is potential or potential difference. V is equal to work done per unit charge. So Q gets divided, or W is equal to VQ. These are the formulas. Then we did for resistance R. R is equal to rho L upon A, where rho is called specific resistance, L is length of the conductor, A is area of cross section. Okay. Then we derived when resistance is in series. In series, R in series is equal to, we have to add all the resistances which are in series, R1 plus R2 plus R3 plus so on. Series means all are connected, all are holding one another hands like this. This is R1, this is R2, this is R3. Then this is called parallel. All are connected to the same point, this point and this point. So all these three are in parallel. These three are in parallel. So current gets divided here, and in series voltage gets divided. Here we get 1 upon R equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus so on. And in case there are two, then R is equal to R1 R2 upon R1 plus R2. And in case all are same value small r, then 1 upon r would be n upon r, or then r would be equal to r small r upon n. R is resistance of each is having resistance of r small r, then divided by number of resistances will get r, in case all are same in parallel. So these are the formula we did for resistances. Then power I told you to learn, V is equal to V into I. Before that we did Ohm's law, that V is equal to IR. Very important formula, Ohm's law. Then P is equal to VI, and I told you when we substitute V from this, I will get P is equal to I square R, or if I substitute in place of I will get P is equal to V square upon R. So these are the formula for power that we did. Then I told you energy is equal to power multiplied by time in seconds. Time is in second. Then we get energy in joules. Okay. Energy is power into time. So in all this formula, you can write energy and put T here. This is the way you can learn the various formulae. Then in case power rating is given, then what we are given? We are given power and we are given voltage. So then what I told you, P is equal to VI. So I is equal to P upon V. And I can also say P equal to, from this formula, V square upon R. So R is equal to V square upon P. So whenever we are given the power rating, we can calculate current and resistance in this manner. So these are the various formulae of this chapter that I had explained to you and we have derived. If you want, you can note it down, then we will proceed further and try to do the numericals. Okay, so now we'll go to numericals. Now, first numerical reads electric fan runs from 230 volt mains. So my V is 230 volt. The current is 0.3 ampere. So I have given the potential difference and current. At what rate is energy transformed by the fan? So what is power? V into I. So this is the power. So this is the how much energy transformed in 1 minute. At what rate when is asking, means is asking the power. So this is the answer for first part. How much energy is transferred? Energy in 1 minute is P into T. T we should take in second. This is the power, which is VI. So this is the energy we have transferred. Quite simple, sir. If you know the formula, you can do it. An electric heater is connected to 10 volt. So again I have given the voltage. In 20 seconds, 30 coulomb of charge flows through it. So time is given, charge is given. So I can find the current. I is equal to Q upon T. So this is the current. Current flowing, so we have done it. Calculate energy transfer in 20 seconds. And time is 20, so energy is power into time. So VI is power, T, if we multiply, we'll get energy transfer. So V is 10 volt, current is 1.5, time is 20 seconds. So this is the energy transfer. Is it all right? So basic formulas you learn, power is equal to V into I. Then you can change the formula by using Ohm's law. V is equal to IR. Is it all right? So we'll go to third sum. Electric bulb is no rating we are given. 220 volt and 100 watt. So it says what is the power consumed at 110 volt. So I should first find the resistance, because resistance of the bulb will remain same. So power is V square upon R. Power is 100 watt. Voltage is 220, so I'll get the value of R. Now this value of R would remain same even in the second case. Value of resistance of an conductor or of any appliance does not change. So when connected to 110 volt, then same formula, power is V square upon R, V is 110 and resistance is 484, so I'll get the power. Is it all right? Then next, calculate the energy transferred by 5 ampere current. So I have given the current and it is flowing through a resistor of 4 ohm. So R is 4, for time is given 1 hour. 1 hour I can convert into second. So what I have done, 60 multiplied by 60. So this is my time. So now I should write power. I have been given current and resistance. So I will say power is I square RT. So power is I square R into T will give me the energy. So substitute the values, we will get the answer. Is it all right? So we'll go to next slide. An electric fan, 200 watt. So again I have given the power. 300 watt lamps. So there are 3 lamps, each of 100 watt and 2 kilowatt heater. We are operating from 7 p.m. to 10 p.m. So this will give me time. So how much time it is operating? For 3 hours. So time is given to be 3 hours. It is connected to 230 volt main. So voltage. What is the cost? So cost means I should find kilowatt hours. I should find kilowatt hours. That is 1 unit. And 1 unit cost is given. So I will calculate how much is the total power first. First always calculate power. 2 kilowatt, so 2. Then 200 watts and 3 of 150. Electric fan is 200 watt, so plus 0.2 is for this fan. Then 3 into 100, 100 watt means 0.1. So this will give me power of my lamp. So I have 3 things, so I have written 3 things. This is 2 kilowatt is heater, 0.2 is fan, and this. So I've got 2.5 kilowatt is the power. Now energy in kilowatt hour means power multiplied by time, and time should be in hours. Now he says he wants a bill for 1 month, so I am multiplying by 30. Multiply by 3 will give me per day, multiply by 30 will give me per month. So this is the energy I am using per month in kilowatt hour, that is unit. You multiply with the cost per unit, you will get the cost of electricity used. Is it okay? So these are the steps for such sums. Whenever they say find the bill or cost of electricity, calculate the power, add all the powers of the appliances that are being used, multiply by the time, and if time is per day, so you have to multiply by 30 days, 30 to get in per month. Sometimes various appliances are being used for different hours. In that case, you can directly calculate energy in kilowatt hour as 2 multiplied by the time, this multiplied by time, 3 multiplied by the time. So multiply by time and directly get total kilowatt hours and multiply with the cost. Now next sum. Calculate the power used in 2 ohm resistance. So only we have to calculate 2 ohm resistance. In for first 6 volt battery is connected in series with 1 ohm and 2 ohm. So you see I have drawn the circuit. 6 volt battery, this is 1 ohm, this is 2 ohm connected in series. Now I want power used by this. What is power used by this? I square R. Power would be I square R because R is given. Now how to get current? So I will find the effective resistance. In series we have to add the resistance. So effective resistance of the circuit would be 1 plus 2, that is 3 ohm. Now once I know the resistance of the circuit, I can calculate the current. Current is V upon R, Ohm's law. Current is V upon R, so I will get the current. Now once I know the current, in series the same current flows through all resistances. So to this 2 ohm also current is 2 ampere, power is I square R, so 2 square into R, I will get 8 watt. So this is the answer. Is it alright? In series circuit, to get effective resistance, add all the resistances and current remains same. So voltage applied upon total resistance will give me the current through all. Is it alright? Now next sum is in parallel. 4 volt battery is in parallel with 12 ohm and 2 ohm. So I have drawn another diagram. This is my 12 ohm, this is my 2 ohm, this is my 4 volt battery. So 4 volt battery is supplying current to these 2 resistances which are in parallel. So in parallel, voltage remains same. Now I have to calculate the power used in 2 ohm resistance. So power is V into I. Now voltage across 2 ohm is 4 volt. So I know voltage across 2 ohm is 4 volt. Voltage across 12 ohm is also 4 volt. But he is asking only against 2. So voltage across 2 ohm is 4 volt. So I know the voltage across 2. Now I want to find the current. Now this 4 volt is the potential drop and 2 ohm is the resistance. So current I is equal to V upon R. So 4 volt upon 2 will give me 2 ampere. So this is the current flowing in 2 ohm resistance. Now power used is I square R. I can use any formula. I can also use V into I. That will also give me V. If I use V into I will get the same answer. What is the voltage? 4. What is the current? 2. So 4 to the 8. So this is the power used in 8 ohm resistance. Okay. I think I will give you few minutes break to revise and then we'll proceed further. So now let us do the next sum. Now level of sums are slightly high. The next sum number 7 reads, there are two wires of the same material of equal length and equal radius. So everything is same. First they are connected in series, so means there is one wire conductor, then another conductor. I am connecting in series, so I am connecting them like this. I am connecting them together. So if this resistance is X, then resistance of this is also X. Both are in series. So what would be the total resistance? So in series, my total resistance would be X plus X, that will give me 2X. And that first we'll consider series case. Question is heat production in the two cases. So first let us consider case 1. Case 1 is a series connection case. Case 1 is series connection case. Resistance of each wire is X. So effective resistance is 2X because I am connecting them in series. Current by using Ohm's law is V upon R. Let V be the potential difference that is applied and resistance is 2X. So this is the current. Now heat produced by Joule's law of heating is I square RT, isn't it? This is the energy. I square R into T will give the energy. So now what is my I? V upon 2X. So V upon 2X square. What is my resistance? 2X. Multiply by 2X into T. So that gives me, if you can do the calculation, simple algebra, it is V square upon T upon 2X. So this is the heat production when the wires are connected in series. In the second case, it says they are connected in parallel. So means now this is my one wire of resistance R, another wire is also of resistance R. I am connecting them in parallel. Here some voltage V is applied. So this is X, this is X. So in case of parallel, I had told you if resistance is R and there are N connections, effective resistance is small r upon N. So now effective resistance of these two would be X upon 2. That's what I have written. Effective resistance would be X upon 2. Even if you have forgotten that formula, you can derive. If R is the effective resistance, 1 upon R would be 1 upon R1 plus 1 upon R2. So this will give me 2 upon R, 1 upon capital R. So my capital R would be small r upon 2. So my effective resistance is X upon 2. Okay, because in this case I am having X. So current is again V upon R. V is potential difference is V and resistance is X upon 2. So 2 would go up. So answer. So I will get current as 2V upon X. Now do the same formula. Heat produces I square RT. Substitute the value of current that we have calculated into R. R is X upon 2. So this is my R. This is my T. You will get, do algebra, you will get this answer. Now you have to take the ratios. Means this upon this. So if you take the ratios, you will get 1:4. Okay. You can work yourself. Any difficulties you can ask me. Otherwise we proceed further. So go to now question number 8. In question number 8, it says electric iron is rated. So again rating is given 220 volt 1 kilowatt. 1 kilowatt means 1000 watt. Under normal working, find the resistance of the heating element. I have explained to you that power is V square upon R, or whenever rating is given, R is equal to V square upon P. So here I have derived it. So R is V square upon P, V is 220, power is 1000, I will get this as the resistance. So I know the resistance now. Second part, current through the element. Current is P upon V, because power is V into I, so I is P upon V. So this formula I told you that whenever rating is given, this formula we have to use. So current is P upon V, P is 1000, V is 220, so this is the current. Even if I have forgotten this formula, you know P is V into I, so look at the value of I. Then it says third part, heat produced in 5 minutes, so time is given. I know the power. Heat produces power into time. How much is power? 1000 watt. How much is time? 5 minutes. 5 minutes means 5 into 60 seconds. It should always be in seconds, so I will get this answer. Heat produced in time t. Then fourth part is power consumed. If voltage falls to 180 volt, if line voltage falls to 180, we know here power is V square upon R. So power is V square upon R, 180 square. R would remain same, which we have calculated here. So I'll get the value of power when the voltage falls. Okay, so if you know the formula thoroughly, you have practice in using them, you can do the numericals. Calculate the electrical energy in kilowatt hour consumed in a month in a house. We are using 2 bulbs of 100 watt. This is similar to what we did one sum previously, and 2 fans of 60 watt. So what is the total power consumed? 2 into 100 plus 2 into 60. This will give me 320 watt, means 0.32 kilowatt. So I know the power. Now they are operating for 10 hours each day, and we have to calculate the bill for 1 month. So I have to multiply by 30, multiply by 10. So this is my time, I will get kilowatt hour. Whenever kilowatt into hour is multiplied, you get kilowatt hour. Now how to 10 hours per day we want to calculate for 1 month. So simple arithmetic, 10 multiplied by 30 will give me total number of hours. Now bill is quite simple, 5 rupees per unit, kilowatt hour is per unit. So multiply by this 96 units by rate, you will get 480 rupees. So this is the bill. Okay. So note it down. Then we'll go to sum number 10. Calculate electrical energy in kilowatt hour consumed in a month. So this is similar sum. Only we have to calculate the kilowatt hour. In a month he is asking. So 2 bulbs of 100 watt each, 2 fans of 60 watt each. Bulbs and fans are operated 10 hours on each day. I think this is the same sum has come, this we have done it. Okay. Now is next sum. All resistances in this figure are in ohm. This is 10 ohm, this is 40 ohm, this is 30 ohm, this is 15 ohm, this is 10 ohm. So all resistances are given. You can see these two are in parallel. So first I have calculated that in 10 and 40, what is the effective resistance? 10 and 40. So we can use that formula, R is equal to R1 R2 upon R1 plus R2. So 10 into 40 upon 10 plus 40. So this will give you 400, this will give you 50, so we are getting 8 ohm. So in place of these two parallel, I can assume I am having a resistance of 8 ohm here. So this is 8 ohm. Now in the same manner, we can remove these 3 parallel and find their effective resistance by using the formula 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So 1 upon R is equal to 1 upon 30 plus 1 upon 15 plus 1 upon 10. 30 would be the LCM. Here you will get 2, here you will get 3. So 3 plus 2, 5, 5 plus 1, 6. So you get 6 upon 30. So 1 upon R is 6 upon 30, R is 30 upon 6, that is 5 ohm. So in place of all these three resistances, I am getting the answer as 5 ohm. So here it is 5 ohm. So I can remove this, here I am getting 5 ohm, here I got 8 ohm. So now they are touching one another hands. So they are in series. You can see this value and this answer, they are in series. So the effective resistance of the circuit would be 5 plus 8, that is 13 ohm. So first part is over. So this is the resistance of the figure. Now current is V upon R. Now I know the effect, he is asking current flowing through the battery. So this is 12 volt, and in place of all these resistances, I am having equivalent to 13 ohm resistance. So my figure is now, this is 12 volt and here is 13 ohm. So by using Ohm's law, I is V upon R. So V is 12 and current is 13. So this is the answer. So this is how you should do the numericals of this chapter. I hope you have understood. But for you to do it in exam, it is very important that you revise all the sums, try to do the sums without looking at the answers which I have heard now. So do the sums till you are able to do independently. Then do similar sums of electricity from the textbook, reference book. You should be able to do any sum given there. So if you have understood this chapter, liked my explanation, you can subscribe to the channel, press the bell icon so that you will get notification when I post the next video, and also you can like the channel. Thank you.